All right, AP Chem Scholars, section 5.8. Now we're taking the idea of mechanisms and rate laws and kind of putting those two ideas together. So when we talked about mechanism earlier on, we mentioned this thing called the rate determining step, the step that takes the most time so it has the biggest impact on the rate of reaction. Okay, so the rate law is based on the rate determining step. That's why it's hard to talk about the theoretical model for a multi-step process, okay? But for an elementary step, it's not so bad. And since every step in a mechanism is an elementary reaction, then the rate determining step, being an elementary reaction, is very easy then to determine the rate law by looking at that. So if we know the slow step, if we know which step is the rate determining step, writing the mechanism is very easy. I want to pause for a moment and say there is a twist to this that we'll have to come back to after we talk about equilibrium. Next section 5.9 is supposed to go into that, but since we haven't talked about equilibrium, I really didn't want to rush in just to squeeze that in. So we'll come back and broaden the picture a little bit once we've talked about equilibrium. All right, so it's going to be a little out of order in that regard. So remember that if we're talking about a rate law, we're expecting coefficients to be the orders or exponents to it. And for an elementary reaction, that is definitely true. So for the rate determining step, that is definitely true. So if we look at our reaction that we've talked about previously, and we said that this first step, because it has more going on, we have to break a bond here before we can make bond. Whereas here, I didn't have to break a bond. Okay, the first step is a slower step. So the first step is the rate determining step. And so I can now look at that, ignore the second step, ignore the overall reaction, and talk about the fact that my reactants are NO2 and F2. They both happen to be gases. I didn't include phases, but I'll tell you that. And so the rate law for this reaction is rate equals K times concentration of NO2 times concentration of fluorine. Both first order because there's a 1 in front. Notice that the reaction is second order overall. It's okay for it to be 0, 1, or 2, 0 first or second order. So this is still an elementary reaction. We're good to go. That is the rate law. That's it. So it's really very simple if we have the mechanism. Okay. So here's a newer example that we did not talk about. So again, these are all gases. So we have NO2 plus CO making NO and CO2. And again, by coincidence, we're told the first step is the slow step. So it says NO2 plus NO2, but realistically, okay, we could just say it's 2 NO2, right? So what is the rate law? All right, so think about it real quick, but it shouldn't take much. Knowing step 1 is the slow step, it's the rate determining step. And since it had a coefficient of 2, the order of the NO2 is 2. And so it's just rate equals K times concentration of NO2. By the way, when the order is, when it is second order, it's referred to as bimolecular. If it is first order, it's unimolecular. Okay, so technically, if there were 3, it would be termolecular, but we're not going to deal really with 3, so I'm not even sure why that would be important to us. All right, so that's it. That's all there is to this. So another short lesson here, pretty simple stuff. And go work in the AP classroom, get that stuff done.